Okay, in lab 2, if you remember, we implemented MapReduce applications using a module named MRJob. In this module, we are supposed to implement two main functions, the reducer function and the mapper function. Then this module runs the MapReduce application and performs computation what we want and what we implemented in this MapReduce application. This week, we are going to implement PageRank algorithm using MapReduce. In the first part of this lab, we implement a non-iterable version of PageRank using MRJob module in Python. After that, we will modify the code somehow to make it iterable. If you remember, we need to iterate MapReduce computation, PageRank MapReduce computation several times to find the accurate PageRank values. Let me share my screen. In the second part of this lab, we will implement the iterable MapReduce application. In fact, we will somehow modify the non-iterable MapReduce implementation to make it suitable to run several times and estimate more accurate PageRank values. Here, we have a web graph. If you remember, we used this web graph as a sample in the lecture last week. In this graph, we have 11 nodes. Each node represents a website. Between these nodes, we have an edge or link. Each edge represents a hyperlink from the source node to the another node. For instance, here we have an edge between A and B websites. It means that there is a hyperlink from node E or from website E to website B. This is the sample graph we are going to use in this lab as an input web graph to the MapReduce PageRank application. But we cannot use directly this web graph as an input to our PageRank algorithm. In fact, we have to convert this web graph into a suitable format, which is anyway readable and which is usable for the PageRank algorithm. If you remember, PageRank algorithm takes text files as input. Here we have the representation of this web graph in terms of a text file. In this text file, each line represents a node in the graph. So here I have this web graph, and I show this web graph here to have the text representation and the graphical representation of the graph in one on the screen. As I told earlier, each line in this text file belongs to a node in the web graph. For instance, we have 11 nodes in this web graph, and here we have 11 lines. Each line represents a node or a website in this web graph. The structure of this line is like this. The first element is node ID. For instance, here D is a node ID, and here we have node D in the web graph. The next field represents the current PageRank value of node D. You might ask why the current PageRank value of node D is equal to 0.090909. If you remember, the first step in PageRank algorithm is initialization step. And in initialization step, each node is given the same PageRank value of 1/n. In this example, we have 11 nodes. So the initial PageRank value of these nodes is equal to 1 divided by 11, which is equal to this 0.090909. The next following fields determine the outgoing links of the node. Here in this graph, node D has two outgoing nodes, A and B. So we list A and B outgoing nodes here. So for C, it's the same. C, it's initial PageRank value and outgoing link. And for each node, we have a line in the same structure here. So as I mentioned earlier, we are going to use this web graph as an input to the PageRank implementation. So please copy and paste this piece of text into a text file named webgraph.txt. So you can connect to the server. Then there are two ways to create this text file on the head node, on the cluster. The first way is to connect to the server, and then first I remove this. Then I open nano web graph.txt, and I can copy and paste this web graph. To save it, I should press Ctrl-O, enter, and to exit, I should press here, Ctrl-X. Now I have this web graph on the head node of the cluster. The other way is to create this file on your local machine and then transfer this webgraph.txt to the head node using WinSCP. So you can, there are two options to create this file on the head node. Now we want to use mrjob module to implement PageRank algorithm. Please note that this implementation here is non-iterable. So we can use this implementation to run PageRank MapReduce only for one iteration. Like before, first we import this module from this mrjob.job package. Here we have a constant value n. N is equal to the number of nodes in the web graph. We have 11 nodes, so we have set n to 11. Then we have a class including two main functions, mapper and reducer. In the mapper, we want to implement the pseudocode we have in slide 9, in the lecture slide. Okay, first, we want to start with mapper function. Mapper function gets as input two parameters, key and input. Key parameters determines the line number in the input text file. Here we have the input text file. So each line has a line number, number 1, number 2, number 3, and so on. So when the mapper get this input file, this input line from the web graph.txt, the key value is equal to 4, and the line variable will be equal to this text, which is d, a number, and 2 outgoing nodes. Suppose we want to process line equal d number AB using this mapper. So the key value here will be 4, and the line parameter is equal to this text. So here we have a string like this. In the pseudocode, we have a function named getOutLinks. This getOutLinks function extracts the outlink nodes of the current under processing node. Here, for this sample line, the current under processing node is the first node ID in the line, which is D. So in this example, D is the current under processing node. GetOutLinks should extract the outgoing links, outgoing nodes from this line. In this example, outgoing nodes of D are A and B. So the output of this getOutLinks should be a list including two nodes, A and B. So here in the code, we want to implement this getOutLinks function. To implement this operation here, first, we split the line into its words. In this line, we have 4 words. The first word is D. Second word is this number, decimal number, and 2 node IDs. In Python, if you run this function on a string, the result will be a list consisting of all words in the string. Here we have line like this, and if I execute line dot split, the output is a list including 4 words. The first word is D, next word is please note that this number is a string. We can see a number, but they are all characters. It is not just a float value. It's a string variable. And then we have A, and finally so the output of this command is a list or an array, including 4 elements. The first element, second element, and following elements we have here. I can just show you this in the Python interactive shell. If I have this line like this, and if I run line split, so as you can see here, the output of this command in Python is a list including 4 elements. Each element is a string. In Python, like C and Java, we can access to each element of a list by an index. So for instance, here, if I store this line.split in a variable named field equal so now fields store this list including each word in the current under processing line. Like C and Java, we can access to each element of this list. List in Python is somehow similar to arrays in C and Java. So we can access to each element of this list by an index. In Python, indexes start from 0. So the first element in this list has index 0. The next one has index 1, index 2, and index 3. So if I want to, for instance, access the index number 1, field 1, and as you can see, it selects this item for me and show it on the display. So if we want to extract the out links of this node, we should select all nodes or all elements in this list which and this indexes equal to or greater than 2. So here we have index 0, index 1, index 2, and 3. If we have a look at all the nodes, all the lines here, all the fields in each line with the indexes greater than or equal to 2 represents the outgoing nodes of the current node. Here, for instance, for E, this is the word element 0, element 1, element 2, 3, 4. Here, element 0, element 1, element 2, and 3. So if we want to extract the outlink nodes of each line, we should select all the elements with indexes greater than or equal to 2. So I can select this kind of elements, to equal. Here it says that select all elements with indexes greater than or equal to 2. So if I run this command, we can see A and B are selected. So here we have outlinks variable equal to fields to column. It means that select all the fields from this fields variable or from this fields list with indexes greater than or equal to 2. So this way, using this line.split and then this index, we extract all the outlink nodes in the current line. The next command in this pseudocode is calculating the PageRank contribution of each node. If you remember, each node donates its PageRank equally to its outgoing nodes. And this command here calculates the amount of PageRank contribution. For instance, here, node Y has a PageRank value of 0.75, and this 0.75 is equally divided between these three nodes. So now we want to implement this command in Python. To implement this command, we need a function named getPageRank. This getPageRank function extract the current PageRank value of the node. For instance, in this line, the current PageRank value of D is equal to 0.090909. So if we want to implement this getPageRank command here, we need to access the field number 1 in this line. So if I run fields with index 1, it will access to the PageRank value. So as you can see here, we have fields 1 to extract the PageRank value of the node. And as I mentioned earlier, this item here is a string. It is not a number. It is not an actual number. It is a string. So we have to convert this string into a float number. That is why here we put float and then we access to the field number 1. This command extract the string, this string, and then this float convert the string into a number. The value of this number is equal to 0.09 and blah, 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 blah. So at the end, we have a PageRank variable, which is equal to a float number 0.090909. So we implemented this get out links by this command, and we extracted the PageRank value of each line here. Now we can obtain the PageRank contribution by this command. So this command divides the current PageRank value of node between here lengths of outlinks, or the size of this set outlinks. Outlinks here is a set. So if we run, if we apply function lengths on this set, the output is the size or cardinality of this link, of this list or set. If I want to show you in Python, outlinks here, outlinks equal to this fits to. Now in outlinks we have the outlink link link nodes of D, and if I execute len outlinks, it will show 2. Why 2? Because in this outlink list we have 2 elements. So now we have the PageRank contribution of node. For instance, in this example, the PageRank contribution of node is equal to the PageRank value divided by 2. This is a PageRank contribution of node D in these 2 websites, A and B. After that, here we have in the pseudocode a for loop. This for loop creates pairs, and each pair has node ID and PageRank contribution. For instance, in this example, Y donates its contribution to nodes A, B, and C. So this for loop yields or emits 3. The first pair is equal to A, and the PageRank contribution, B, PageRank contribution received from Y, and so on. So to implement this for loop here, we write for a variable name. It's like a counter, just count in this set. This set contains all the outlink nodes of the current under processing node. And then it emits the node ID and PageRank contribution. For instance, here, this for loop in this example returns 3 pairs. The first 2 pairs, sorry. The first pair is A as key and the PageRank contribution here and PageRank contribution. And the second pair is like this. So this for loop iterates 2 times. Why? Because we have 2 elements in out links. In out links, we have 2 elements. Out links, and we have 2 elements in this list. And for each element, it emits a pair with the key value of the node ID and the value of PageRank contribution. So this is the mapper function. So we implemented this pseudocode in Python. After that, it comes to reducer. In the reducer, we want to aggregate all pairs with the same key values. So here, the reducer gets as input an MID and a set consisting of all PageRank contributions. If I want to explain these parameters by this example here, in reducer, MID is equal to A. Suppose for this node A, this reducer gets 2 pairs. One pair is this one, and another pair, so just it's only a random number. Another pair, for instance, for A, comes from another node, and the PageRank contribution is this one. So suppose the mappers produce 2 pairs with the same key values A. Then the reducer receives these 2 pairs produced by the mappers. So MID for these 2 pairs will be A, and values is a set or a list of 2 numbers, this number and this. So I only just now I generated this pair randomly, just it's a random number and it's a random pair. Just purely as an example to explain what reducer does. So MID in this example with these two pairs is equal to A because the reducer get all pairs with the same key value. So here we have two pairs with the same key value A. So this reducer gets these two pairs to aggregate them. So MID is A and values is a list consisting of these two page contributions. 8.9. If you have a look at the pseudocode, first we should obtain the sum of these two PageRank contributions. Here we have S equal to sum and the list of PageRank contributions. So as you can see here, we have S equal to sum and values here is a list. In Python, if we give a list to function sum, this function returns the sum value of these two, all the elements in the list. For instance, if I have here a values list with two elements like this, and if I run sum values, this command returns this sum value of these two numbers. If we have, I don't know, for instance, 10 numbers in this list, it will add, this command will add all these 10 numbers, and the result will be the summation of all these 10 numbers. Then, as we have here, we should compute the new PageRank value of the node. So as we can see here, 0.85 multiplied with S here is the summation of all values or all PageRank contributions, plus 0.15 divided by n, divided by the number of nodes. And finally, we should emit the result, MID and its PageRank value. So the output of this the output is equal. First, we should compute S. Here we have the value of S, a summation of these two values. Then my PageRank is equal to my PageRank is equal to 0.85 multiply S plus 10/11, and this is the new PageRank value for A. And at the end, the reducer emits A, comma, So this is what reducers perform. So if I want to briefly explain, the mappers obtain the PageRank contribution of each node, and then reducers accumulate the PageRank contributions for each node. And the results will be the new PageRank value for every node we have here. So in the first part of this lab, please, as I explained earlier, create this webgraph.txt file and copy and paste these 11 lines in it. Then write this code in a Python file named mr_pagerank1.py. This is anyway a Python application, and we have this PageRank implementation here. Then please run this application on the head node of cluster using this command. Okay, for the first part, please implement this. Then we will continue the lab with implementing the iterable version of PageRank. Okay. In the first part of this lab, we implemented a non-iterative version of PageRank in MapReduce. Now, we want to modify this implementation somehow to make it ready to run in more than one iteration. So in fact, we want to implement an iterative version of this PageRank algorithm using MapReduce. Here we have the code, an iterative PageRank algorithm in MapReduce. As we can see here, we have again two functions, mapper and reducer. Like before, the mapper is responsible to find the PageRank contributions, and the reducer main responsibility is to accumulate or aggregate all the pairs with the same key value. But as I explained in the lecture here in this slide, in the non-iterable MapReduce implementation, the output of reducers cannot be used in the next mappers. Why? Because the output of reducers is a pair including node ID and its new PageRank value. And we don't have any ongoing node IDs here. But in the input, apart from node ID and PageRank value, we need to have outlink nodes of each node. So in the modified PageRank, we should address this problem. In fact, we should make we should modify reducers to output the outlink nodes of all under processing nodes. In fact, we want to see all the outlink nodes of each node after, in the pairs produced by reducers. So in the modified version of this MapReduce application, or in the iterable version of this PageRank algorithm, the output pair, for instance, for A, should be like A 0.31 and FG. F and G here are the outlink nodes of A. So the modified reducer should include these two outlink nodes here. Now we want to implement such a MapReduce application. We have the pseudocode for the iterable MapReduce for PageRank in slides 16 and 17. First, we start with the mapper function. All the blue lines here we implemented in the previous mapper. So in this mapper, we have all these, I don't know, for instance, page ranks, outlinks, and everything, and page rank contribution, and this for loop. We have implemented all of them yet. Here we have one more function in the modified MapReduce, the modified map function. We have one new function, get ID. This get ID returns the node, the ID of under processing node. For instance, if the under processing line is this line for node D, as I mentioned earlier, node D representing the under processing node. So this get ID function extract this under processing node from this line, from this string. Like before, to extract one information or something from this line, we can split this line and then select the desirable element. Here, in this example, the desirable element is node ID, which is the first element in this list. So after we split this line into words, the first element with index 0 is the desirable value we are looking for, or the desirable field we are looking for. So to obtain the node ID of current under processing node, we access to the index number 0 in fields. If you remember, we split the line into some fields, and then the element with index 0 is the node ID of current under processing node. So this get ID function is implemented by this line. After that, here we want to implement this emit command. if you remember, this emit command emit out link list of the under processing node. For instance, in this example, the outlink nodes of Y are 3 nodes, A, B, and C. So this yield command creates a pair like this. The key value in this pair is Y, the node ID of this node which is under process, and its outlink nodes, which are A, B, and C. So to implement this command in Python, or to implement this line in Python, we write like this: yield my ID, as I explained earlier. Here, this is, for instance, in this example, D, and the element with index 0. And then out links. We obtained out links earlier in the previous mapper. And here, out links is equal to the elements with the index values greater than or equal to 2. So this yield emits the ID of under processing node and its outgoing links. For instance, in this example, this command, this yield command, will create a pair with the key value D, because here D is the node ID we are processing, D, and a list. In this list, we have outlink nodes, which are A and so this mapper, apart from emitting the PageRank contributions, returns the outgoing nodes of each node. So if we look at this graph, for node D, for instance, the mapper of outgoing nodes, which are A and B. So we have A and B here. This is a pair. The first element is key, which is D, and the value for this pair is a set including 2 nodes, the outgoing nodes of node D, for instance, in this example. And like before, the mapper emits the PageRank contribution of node D in the PageRank values of A and B. So yes, like here. Oh, sorry, I should write. It's better to write this here. So this is the first yield in the map, in the new mapper, and this is the 2 pairs produced by this for loop, emitting the PageRank contributions for A and B. So in the new mapper, we only added 2 lines. The first line extracting the node ID of the current page we are processing, and 1 command creating a pair including the current node ID and its outgoing links. And here we have the output for this sample line. A pair produced by this command and pairs produced by this and this emit command here. Then we need to implement reducer function. The reducer function should process two sets of pairs. The first set is like before, the PageRank contribution pairs. So like before, for instance, for node A, this reducer you don't have my voice. Hello.
We can hear you. I don't know if Syed.
Hello,
maybe
I can hear you.
Yeah.
Because you know, I in the chat, one of you said that no voice.
I mean, we can hear you. I don't know about
Yeah.
Syed. Maybe he muted his computer or something. But
Yeah, Said Abdul, there is something wrong with your sound in computer sound. So please go through the setting. So here I'm unmuted and everything is good. Okay. So in the reducer, like before, we have to accumulate or aggregate the pairs with the same values for key. So like before, for instance, here, this is an example we used in the previous MapReduce. Here, this reducer gets two pairs, two contributions for A. Apart from these two contributions, it gets another pair. This pair determines the outgoing links for A, which are A, for instance, a list including F and so in the previous application, the reducer only get the PageRank contributions. So the pairs received by the mappers look like pairs like this. So we have pairs like page, node ID and the PageRank contribution. But in the modified reducer, we will get this set of pairs and a pair like a adjacency pair. In this pair, we have the node ID and its outlink nodes. These two sets of pair produced by mappers. So here in the mapper, we have two emit commands, one here and one in this for loop. So the reducers will get two sets of pairs, one like this outgoing links pair, and the other pair here is the PageRank contribution. If we have a look at the pseudocode for iterable MapReduce, the reduce function here, everything is the same, but we have one if block. In this if block, we process the outlink nodes. So this if block is responsible to process the outlink nodes or the pairs involving the outlink nodes of the current under processing node. Here we want to implement this if block. As I mentioned in this example, the reducer gets two different sets of pairs. This if block is responsible to distinguish or to separate outlink pairs from PageRank contribution pairs. Here we have a command isInstance. IsInstance is a function in Python. And using this function, we can check the data type of a variable. For instance, in Python, if I write something like this, if I create a list like, for instance, F and G. So A is a list. If I is in instance A, comma, list. So with this command, I want to check the data type of this A variable. I want to see if this A is a list or it is a float number or I don't know, a set or something else. So if I run this isInstance A, comma, list, it will show me true. Why? Because A is a list and the output of this isInstance is true. But if I have an integer number here, B is an integer number, and if I call this command isInstance B, comma, list, B is not a data type of list. And as we can see here, the output of this isInstance is not true, it is false. Why? Because B is not a list. B is an integer number. So we use this isInstance in the reducer to separate this kind of pairs from the other set of pairs. So here we say that if the value in the values, so you know that values is a list of all a list including the value field of all these pairs. So in this example, the values for this reducer is the PageRank contributions and a set including F and G. So here in this example, MID is equal to the PageRank to the node ID A, and the values is a set including the value field of all these pairs for A. So we have these two numbers and a set inside this set with two items. This for loop here go through this set and access each element in this set one by one. It's a for loop. So iterate in this set in values. Here we check if this value is a list or not. If this element is a number, so like before, we add this value to the to S. Like before, here we add all the PageRank values. In the previous reducer, we add all the PageRank values. But here in this set, we have some numbers and some sets. That's why we should check if this value we are anyway. Now we are processing in this for loop. If this is a number, so we add it. But if this is a set, here we set m out links equal to ban. So if this is a number, we add to S, we add this number with S. But if the value is a set, so we set m out links equal to this set. So using this if command, we can separate sets from numbers. All numbers in this values set are added together, but the only set in this set are extracted and we save it in a variable named moutlinks. And here we can see moutlinks. Then after that, everything is the same as previous reducer. So we have S, so we use the PageRank formula to obtain the PageRank contribution. And at the end, we create the output pair. In the output pair, we have the node ID. Like before, we have the PageRank value, and we have a list of outlink nodes. So the output will be something like this: node ID, PageRank value, and a list of outlink nodes. But we have something more here in this yield command. Now I explain what's the meaning of this extra, I don't know, plus, quotations, join, and everything. But anyway, in this reducer, we have two different sets of pairs. And using this if, we separate the sets from value numbers in these values variable. And this is the output line, which is something like this. Okay. Now I'm going to explain what is the meaning of this plus these quotations, join, and everything. The output of reducer is a string. So here we create that string, the output string of reducer. In Python, if we want to merge, if we want to merge two strings together, we can use plus operation. For instance, if I have one string, for instance, st1 equal to this is, and I have another string 2 equal to space test. So here I have two string 1 and string 2. If I want to merge these two strings together, I can use plus operation. So string 3 equal to string 1 plus string 2. And the result is string 3. And as we can see here, this plus operation merge this is and a test together. And the output is this is a test. So here we do something like this. MID is a test, is a string. Like, for instance, in this example, D. Sorry, A. MID is A. So here in the output, it creates something like this. And a string A plus. Here, we have double quotations. It means that puts a space. So here we have, I add a space plus. PageRank is a number, because this is some calculations and the output is a number, but I need the string value of this number. So here I don't like before, for instance, like before we had this string and using this was PageRank. So suppose PR is equal to this string. If I write float PR, this command returns a float number. And now here, if I number equal this one, the number will be equal to this 0.099. If I want to convert this number to a string, I should do like this: 0 str no. So the output of this command will be a string including these characters 0.090909. So this is not a number, this is a string. So here I want to convert a number to a string. And as we can see, I put the number variable inside this string, and the output will be an string. So here, PageRank, the value of PageRank is this. So if I put here str value, the output will be something like this. And then here we add this string here. After that, we attach one space here. And we have join. Join is a function attach a list to a string. So in Python, suppose we have this a, we have list A, including two elements, F and G. And I have an string named string3. If I want to join this list, if I want to add this list to string3, I can write string3 dot join A. Here, this join, I think it's better to write like this, plus so here we have a string3. A string3 is, this is a test. And then I can join this set, this list, to the, this is a test a string by this command. So here, using this join command, we attach the values in this list to the string. And at the end, the output of reducer will be something like this. A node ID, its PageRank, and all its outlink nodes. They are all Python commands. Join if you work with join in a database. So join in Python is something similar to join in SQL. But anyway, this line creates the output of reducer. So the mapper creates two sets of pairs, and the reducer processes these two sets to produce a pair or a text line including node ID, its new PageRank value, and the all outgoing links of outgoing nodes of MID. And this is the reducer. So we can use this map and reduce function in an iterative application. So we can run these two mapper and reducer several times to obtain the more accurate PageRank values. But you might ask how we can run these mappers and reducers for several times. Here we have a function named steps. Using this function, we can determine the number of iterations. In fact, we can determine how many times this map and reducer functions are called. In a steps function, we should do two things. First, we should create a job. Here, we have created a job. This job performs two tasks. The first task is running the mapper function here. Self.mapper represents this function here. So in this job, the first task is to run the mapper function. After that, it will run the reducer function. So here self.reducer is pointing to this reducer function. So using this MR step, we create a job consisting of two tasks. The first task is mapper, and the second task is reducer. The first task mapper, and the second task reducer. Why we have created such kind of task? Because in iterative job, in iterative MapReduce, we want to run mapper, after that reducer. Then we want to repeat the same job. Again, mapper and reducer. Next iteration, the same. And we want to repeat one job several times. So here we have created that job, including one mapper. Here we have defined this mapper and one reducer. So here we have this reducer. Okay, now we have a job like this. So this is our job. This is our job, including some map and reduce. Map and reduce. Now we want to repeat this job for several times. In fact, we want to repeat this map and reduce task for this number of iterations. N iteration, this N iter determines the number of iterations. For instance, I want to iterate this map and reduce operations for 50 times. That is why I defined a constant and set the constant to 50. You can change the value of this constant and iteration variable. I don't know if you want to repeat this MapReduce application instead of 40 times. If you want to repeat, I don't know, for instance, 10 times, you can set here n iteration equal to 10. So here we have defined one job, including one mapper and one reducer. Now we want to create a larger job, including 50 iterations of this job. So in Python, if you multiply a set by a number, the result will be a set including, actually the output consists of n iteration elements of this value here. So I want to just, I can show you by one example here. Suppose we have a list. This is a list and we have only one item here, A. If I multiply this list by 10, the output, as we can see here, is a list including 10A. So in Python, we can multiply a list by an integer number, and the output repeats the elements in the set. So here, if I run this if I multiply this list by 5, so in the output I have 5A. Here we do the same. We have a set including one job, one MapReduce job. Now I want to create a larger job consisting of 50 MapReduce job. So if I multiply this small job, this small MapReduce job by 50, at the end I will get 50 iteration, 50 MapReduce iteration. So it means that here I have 50 MapReduce iteration. Okay, if you run this application, you will see that the step function will create a job consisting of 50 MapReduce jobs, and then you can see that 50 iteration of this map and reducer functions. So please copy and paste this code in this Python script file and then run your application by issuing this command. In the first time, you can set the number of iteration to 1, and you will see that the output for n iteration equal to 1 will be the same as the values you got here. And after that, please increase the number of iterations. You can increase, I don't know, one time 5. You can set num iteration to 5, then 10, 20, and then 50. And as you increase the number of iterations, the page rank value you get get more accurate. With increasing the number of iterations, the accuracy of page rank values increase. Okay, that's all. Okay, and one thing more. Here in the code, we have output protocol equal to raw value protocol. We add this line because we don't want to this MapReduce class reform the output text. Without this, the output text will be automatically reformed by this class. But when we add this line, the output will be what we have created here, exactly what we created here. So nothing added or removed from this text. Because usually in Python, the input file is the default input file is in the format of JSON file. But here we only need to have raw values. That's why we add this line to avoid Python reforming the output text. Yeah, and here we imported two modules. This protocol because we want to avoid any reforming tasks, and we want to get in the output exactly a string like this, and MR step to define this function and use it to iterate the MapReduce application. Okay.